The first salvo arrives without warning. German soldiers dug into defensive positions outside Smolensk hear a strange sound, a rushing, howling noise unlike anything they have encountered before. Then the world erupts around them. Explosions tear through their positions in rapid succession, not the methodical bombardment of artillery that they have grown accustomed to, but a sudden, overwhelming storm of fire that lasts only seconds but leaves devastation in its wake. Men are killed, wounded, or driven mad by the intensity. Those who survive are left shaken, disoriented, their defensive positions shattered. The attack came so quickly that there was no time to take cover, no time to respond. As the smoke clears and the survivors try to understand what hit them, they hear the sound again, another salvo incoming. This is their introduction to the Katyusha, the Soviet multiple rocket launcher that will become one of the most feared weapons on the Eastern Front. The Germans will call it Stalin's organ because of the sound it makes when firing. Soviet soldiers will call it Katyusha after a popular wartime love song. By any name, it represents a revolution in artillery warfare, a weapon that can deliver massive firepower in seconds, saturate an area with high explosives, and then disappear before the enemy can respond. This is the story of how Soviet engineers developed a weapon that terrorized German troops and changed the nature of artillery combat. The development of the Katyusha begins in the 1930s, during a period when the Soviet Union was rapidly industrializing and modernizing its military. Soviet military planners were interested in rocket technology as a potential alternative or supplement to conventional artillery. Rockets had certain theoretical advantages over gun-fired artillery shells. A rocket did not require a heavy gun barrel to contain and direct the explosive force. The propellant could be carried within the projectile itself, making the launcher much lighter and simpler than an artillery piece. This meant that rocket launchers could potentially be more mobile and less expensive to produce than conventional artillery. However, rockets also had significant disadvantages. They were inherently less accurate than gun-fired shells because they were not stabilized by rifling in a barrel. A shell fired from a rifled gun spins, which stabilizes it in flight through gyroscopic effect. A rocket has no such stabilization unless it is designed with fins or some other stabilization system. Rockets were also more complex to manufacture than artillery shells because they had to contain both the explosive warhead and the propellant in a single package. The propellant had to burn in a controlled manner to provide thrust throughout the rocket's flight, which required careful design and quality control in manufacturing. Despite these challenges, Soviet engineers believed that rockets could be useful for certain applications. The key insight was that while individual rockets might not be very accurate, a large number of rockets fired simultaneously at the same target area could saturate that area with explosives, compensating for the lack of precision with sheer volume of fire. This concept, known as area saturation, became the foundation for the Katyusha's tactical employment. The technical development was led by several Soviet scientists and engineers working at different research institutions. Georgy Langemak and his team at the Gas Dynamics Laboratory in Leningrad developed various rocket designs and propellants. Andrei Kostikov worked on rocket motors and stabilization systems. The work progressed through the 1930s, with various experimental rockets being designed, tested, and refined. By 1938, the Soviets had developed a solid-fuel rocket that showed promise for military use. This rocket, designated the RS-82, was an unguided air-to-ground rocket initially designed to be fired from aircraft against ground targets. The RS-132 was a larger version with a 130 tomb diameter, which became the basis for the ground-based Katyusha system. The rocket was about 6 feet long and weighed about 92 pounds, including a warhead containing about 10 pounds of high explosive. The rocket motor used a solid propellant that burned for several seconds, accelerating the rocket to a speed of several hundred feet per second. The rocket was stabilized in flight by fins at the rear, which helped to keep it pointed in the right direction, though accuracy was still limited compared to conventional artillery. The launcher itself was brilliantly simple. Rather than developing a complex, heavy-firing system, Soviet engineers mounted the rockets on a framework of rails attached to the bed of a truck. The BM-13, which became the most common and famous Katyusha variant, consisted of 16 launching rails mounted on a ZIS-6 six-wheeled truck. The rails were angled upward, allowing the rockets to be launched at an elevation that would give them the desired range. The entire launcher could be elevated or traversed to aim at different targets within a limited arc. The loading process was relatively simple. Each rocket had a small stick or rod extending from its rear that fit into a groove in the launching rail. Crew members would slide the rocket onto the rail from the rear, and the rocket's own weight would hold it in place. Once all 16 rails were loaded with rockets, the crew would connect electrical firing wires to each rocket. The firing was controlled from the cab of the truck, where the commander had a simple electrical firing system. He could fire the rockets individually, in sequence, or all at once. The standard firing procedure was to launch all 16 rockets in a rapid sequence, with each rocket firing a fraction of a second after the previous one. This created the distinctive rippling effect and the howling sound that gave the weapon its German nickname. The entire salvo could be fired in about 7 to 10 seconds, depending on the electrical firing system and the specific procedures used. Some accounts mention salvos as quick as 7 seconds, others mention slightly longer times, but the key point is that all 16 rockets would be in the air in less than 10 seconds, creating an instantaneous and devastating bombardment. The effect of this rapid fire was both physical and psychological. Physically, 16 rockets each carrying 10 pounds of high explosive meant 160 pounds of explosives landing in the target area within seconds. Each rocket created an explosion with significant blast and fragmentation effects. Personnel in the open would be killed or wounded by the blast waves and flying shrapnel. Vehicles could be damaged or destroyed. Light fortifications could be demolished. Even heavy fortifications would be shaken, and the occupants would be stunned by the concussions. But the psychological effect was perhaps even more significant. Traditional artillery bombardments, while deadly, followed a pattern that soldiers could learn to cope with. You would hear the guns firing in the distance, then hear the shells whistling through the air, then the explosions. There would be a pause while the artillery reloaded and fired again. Experienced soldiers learned to time these patterns, to take cover when they heard incoming shells, to move during pauses in the bombardment. The Katyusha broke all these patterns. There was no warning sound of guns firing because the launcher was silent until the rockets ignited. The rockets themselves made a horrible screaming or howling sound as they flew, very different from the whistle of artillery shells. The entire salvo arrived almost simultaneously, giving no time to react. One moment everything was normal, The next moment explosions were tearing through your position. Then, just as suddenly, it was over. This sudden, intense bombardment followed by immediate silence was deeply unnerving. Soldiers never knew when another salvo might arrive. The conventional artillery doctrine of the time involved sustained bombardments that might last for hours, but the Katyusha's doctrine was different. Fire a salvo, relocate, fire again from a new position. This hit-and-run approach made Katyushas very difficult to counter with counter-battery fire. By the time German artillery or aircraft could respond to a Katyusha position, the launcher would be gone, already moving to a new firing position or back to a concealed location. The first combat use of the Katyusha occurred on July 14, 1941, less than a month after Germany invaded the Soviet Union in Operation Barbarossa. A Katyusha battery commanded by Captain Ivan Flyorov fired on German positions near the railway station in Orsha, in what is now Belarus. The attack was a complete surprise to the Germans. The sudden barrage of explosions caused panic and significant casualties. German troops had never encountered anything like it. In the chaos of the initial weeks of the war, when German forces were advancing rapidly and Soviet forces were in disarray, the appearance of this new weapon was both a tactical success and a psychological boost for Soviet forces. The Soviet leadership recognized the value of the Katyusha immediately and ordered rapid expansion of production. The weapon was designated a state secret. Guards units were specifically assigned to Katyusha batteries, with orders to destroy the equipment rather than let it fall into German hands. This secrecy was maintained rigorously in the early months. Katyusha crews were told not to discuss the weapon with anyone. Units were deployed carefully, often at night, and firing positions were chosen to minimize the chances of the weapon being observed or captured. Despite these precautions, German forces eventually captured damaged Katyusha launchers and unexploded rockets. German intelligence analyzed the weapon and quickly understood its design and operating principles. However, understanding how it worked did not make it any less effective or any easier to counter. The Germans developed their own multiple rocket launchers later in the war, including the Nebelwerfer, but they never deployed them in the same numbers as the Soviets deployed Katyushas. The production of Katyushas increased dramatically as the war progressed. Soviet factories, many of which had been evacuated eastward to the Urals and Siberia to escape the German advance, began mass-producing the launchers and rockets. The design was well suited to mass production. The rockets themselves were relatively simple, consisting of a steel tube for the motor, a warhead, fins, and the solid propellant. Quality control was not as stringent as it would be for precision weapons, which meant production could be scaled up quickly. Some rockets were better made than others, which contributed to variation in accuracy, but this was acceptable given the area saturation doctrine. The truck chassis used for the BM-13 were American-made, provided through the Lend-Lease program. The Soviet Union received thousands of Studebaker US-6 trucks from the United States, and many of these were converted into Katyusha carriers. The Studebaker was reliable, had good off-road capability, and could carry the weight of the launcher and a crew of 5 to 7 men. The use of American trucks for such an iconic Soviet weapon is one of the interesting footnotes of World War II, demonstrating the importance of Allied cooperation. Other variants of the Katyusha were developed during the war. The BM-8 fired smaller 82 rockets from 36 or 48 launching rails, providing even more rockets per salvo, though with smaller individual warheads. The BM-31 fired much larger 300 rockets from a 12-rail launcher, providing heavier individual warheads at the cost of fewer rockets per salvo and longer reload times. There were also light infantry versions that could be carried by troops and fired from simple frames or improvised mounts. The Soviets even mounted some Katyushas on light tanks, creating self-propelled versions with better mobility and some armor protection. The tactical employment of Katyushas evolved throughout the war. Initially, they were used for defensive fire, breaking up German attacks or bombarding German assembly areas. As Soviet forces transitioned to the offensive in 1943 and beyond, Katyushas became key weapons in preparing attacks. Before a Soviet offensive, Katyusha batteries would saturate German defensive positions, destroying fortifications, cutting wire, and suppressing defenders. The intensity and suddenness of these bombardments disrupted German defensive plans and reduced the effectiveness of their response to the subsequent Soviet infantry and tank attacks. Katyusha units were typically organized into batteries of 4 launchers, and multiple batteries would be grouped into divisions or regiments. These units could concentrate enormous firepower on relatively small areas. A regiment of Katyushas might have 36 launchers, capable of firing 576 rockets in a single salvo. When multiple regiments were concentrated for major offensives, the number of rockets fired in the opening barrage could be in the thousands. The effect on German positions was devastating. Entire defensive sectors could be pulverized in minutes. The sound of the Katyusha firing became one of the iconic sounds of the Eastern Front. Soviet soldiers and later civilians in liberated territories learned to recognize it. The howling of the rockets in flight and the rapid succession of explosions were sounds of hope and impending victory. For German soldiers, these same sounds meant terror and death. The Germans called it Stalin's organ, Stalinorgel, because the multiple rockets firing in sequence reminded them of the pipes of a church organ, all playing different notes simultaneously. The nickname captures both the awe and the fear that the weapon inspired. German soldiers wrote in letters and diaries about their experiences under Katyusha fire. The accounts are remarkably consistent in describing the psychological impact, the suddenness of the attack, the inability to predict when it would come, the horrible sound of the rockets, the intensity of the explosions, all combined to create a sense of helplessness. Some soldiers described panicking during Katyusha attacks, abandoning their positions to seek shelter anywhere they could find it. Even experienced troops who had survived conventional artillery bombardments found Katyusha attacks uniquely terrifying. The German response to the Katyusha threat was multifaceted. They attempted to locate and destroy Katyusha batteries with counter-battery fire, but this was difficult because of the shoot-and-scoot tactics the Soviets employed. German aircraft were directed to hunt for Katyushas, but Soviet air defenses and fighter coverage made this dangerous, and the Katyushas were often well camouflaged when not firing. German ground forces tried to capture or destroy Katyushas during advances, but the weapons were usually withdrawn before German troops could reach them. The Germans also attempted to reduce the effectiveness of Katyusha attacks through dispersion and improved fortifications. By spreading out troops and equipment rather than concentrating them, the Germans could reduce casualties from any single Katyusha salvo. Deeper, stronger bunkers could provide better protection against the explosions. However, these countermeasures were only partially effective and came with their own costs. Dispersed forces were harder to coordinate and command. Building elaborate fortifications took time and resources. The Katyusha forced the Germans to adapt their tactics, and these adaptations often made their operations less efficient. The accuracy of the Katyusha was actually quite poor by the standards of conventional artillery. An individual rocket might land anywhere within several hundred yards of the aiming point, and the dispersion of a 16-rocket salvo could be considerable. However, this lack of precision was offset by the volume of fire and the area saturation approach. The Katyusha was not designed to destroy a specific tank or gun position. It was designed to bombard an entire area, an assembly point, a defensive sector, a crossroads, and within that area, the density of explosions would be high enough to cause significant damage. The Soviets understood this limitation and used the weapon accordingly. Katyusha fire was directed at area targets, not point targets. When used in conjunction with conventional artillery, which could provide more precise fire, the Katyusha added volume and shock effect. Soviet offensive doctrine typically called for a preparatory bombardment involving both conventional artillery and Katyushas. The artillery would suppress specific strongpoints and destroy identified targets, while the Katyushas would saturate the entire defensive zone, adding to the destruction and maximizing the psychological impact. The reload time for a Katyusha was significant, typically 10 to 15 minutes for a well-trained crew. The crew had to manhandle 16 heavy rockets from their transport vehicle to the launcher, slide each one onto its rail, and connect the firing wires. This physical labor was exhausting, especially under combat conditions. However, the Soviets often used Katyushas in a time-on-target fashion, where multiple batteries would fire their salvos to arrive simultaneously, then all would withdraw and reload. This created pulses of intense fire followed by periods of relative calm, while the batteries reloaded and repositioned. The logistics of supporting Katyusha units were substantial. Each rocket weighed about 92 pounds for the 132 version, so a battery of 4 launchers firing a single salvo would expend 64 rockets, weighing nearly 6,000 pounds. Firing multiple salvos required trucks dedicated to carrying rockets forward to the batteries. The Soviets developed specialized rocket transport vehicles and organized supply chains specifically for Katyusha ammunition. This logistical tail was necessary to keep the weapons supplied and firing. The morale effect of the Katyusha on Soviet troops was as significant as its demoralizing effect on German troops. For Soviet soldiers, hearing Katyusha salvos firing meant that their artillery was supporting them, that the offensive was being prepared properly, that the leadership was committing powerful weapons to help them succeed. The distinctive sound of the Katyusha became associated with Soviet offensives and victories. Soldiers took pride in the weapon, seeing it as uniquely Soviet and a symbol of the Red Army's growing strength. The name Katyusha itself is interesting. It was not an official military designation, but rather a nickname that became universally adopted. Katyusha is the diminutive form of the Russian name Yekaterina, similar to Katy or Cassie in English. It was also the name of a popular Soviet song written in 1938 about a young woman longing for her beloved who is far away serving in the military. The song was enormously popular during the war, and soldiers began calling the rocket launcher Katyusha, possibly because the rockets screamed through the air like a woman's voice, or possibly just because the name sounded affectionate and humanized the weapon. The nickname stuck and became official usage even in military documents. The use of Katyushas expanded throughout the war. They were used in every major Soviet offensive from 1942 onward. At the Battle of Stalingrad, Katyushas bombarded German positions within the city and later helped to trap the German Sixth Army in the encirclement. During Operation Bagration in the summer of 1944, the massive Soviet offensive that destroyed German Army Group Center, Katyushas were used extensively in the preparatory bombardments. In the final assault on Berlin in 1945, Katyushas fired on German defensive positions in and around the city. The Soviets also shared Katyusha technology with their allies. Communist partisan groups in Yugoslavia and other occupied countries received some Katyushas or the technical knowledge to build their own simple versions. After the war, the Soviet Union exported Katyusha-type systems to allied nations, and the design was copied and modified by various countries. The Chinese produced their own versions, as did North Korea. During the Cold War, Soviet-style multiple rocket launchers became standard equipment in the armies of the Warsaw Pact and other Soviet-aligned nations. The German development of their own multiple rocket launchers, the Nebelwerfer family, was influenced at least partially by encountering Soviet Katyushas. The Nebelwerfer, which means smoke thrower in German, was originally designed to lay smoke screens, but rocket versions were developed that fired high explosive projectiles. The German 15 cm Nebelwerfer 41 fired 6 rockets from a launcher that looked like a cluster of tubes. It was effective, but was never produced or deployed in the same quantities as the Katyusha, and it lacked the mobility of the truck-mounted Soviet system. The Americans and British also developed multiple rocket launchers during the war. The American T-34 Calliope mounted a bank of rocket tubes on top of a Sherman tank. British forces used various land matrix and other rocket systems. However, none of these Western Allied rocket systems achieved the same iconic status or were used as extensively as the Soviet Katyusha. This was partly because Western Allied doctrine relied more heavily on conventional artillery, which the Americans and British had in abundance, and partly because the specific tactical situation on the Eastern Front, with its vast distances and large-scale offensives, was particularly well suited to weapons like the Katyusha. The evolution of Soviet rocket artillery continued after World War II. The basic concept pioneered by the Katyusha, a truck-mounted multiple rocket launcher capable of rapid fire and high mobility, became the foundation for subsequent Soviet and Russian rocket artillery systems. The BM-21 Grad, introduced in the 1960s, was a direct descendant of the Katyusha, using a similar concept but with more modern rockets and fire control systems. The BM-27 Uragan and BM-30 Smerch followed, each generation increasing in range, accuracy, and destructive power. Modern Russian systems can fire guided rockets with GPS or inertial guidance, dramatically improving accuracy while retaining the area saturation capability. The influence of the Katyusha on artillery doctrine was profound. The weapon demonstrated that multiple rocket launchers could provide a unique combination of mobility, firepower, and shock effect that complemented conventional tube artillery. After the war, most major armies incorporated multiple rocket launchers into their artillery forces. The basic principles established by the Katyusha, rapid fire of multiple rockets from a mobile platform, area saturation of the target zone, and quick relocation after firing, became standard doctrine for rocket artillery worldwide. The manufacturing simplicity of the Katyusha was one of its great strengths, particularly in the context of the Soviet war effort. The Soviet Union lost much of its industrial base in 1941 as German forces occupied the western regions where most Soviet industry was located. Factories were evacuated eastward under incredibly difficult conditions, dismantled, transporting hundreds or thousands of miles by rail, and reassembled in the Urals, Siberia, and Central Asia. These factories had to begin production quickly with limited tools, materials, and skilled workers. The Katyusha, with its relatively simple design, was well suited to this environment. It did not require the precision machining needed for artillery pieces or the complex metallurgy needed for tank armor. Steel tubes, solid propellant, simple fins, and truck chassis were all that was needed. The political importance of the Katyusha should not be underestimated. Stalin and the Soviet leadership were intensely interested in weapons that could demonstrate Soviet technical capability and military power. The Katyusha became a symbol of Soviet innovation and strength. It was featured in propaganda, in films, in posters. Monuments to Katyusha units were erected. The weapon became part of Soviet military identity and national pride. After the war, this symbolic importance continued, with Katyushas appearing in victory parades and serving as monuments in cities across the Soviet Union and later Russia. The sound of the Katyusha was so distinctive and so associated with the weapon that it became a signature of Soviet military power. Recordings of Katyusha salvos were used in Soviet military documentaries and films. The howling of the rockets, the rippling explosions, these sounds conveyed power and invoked the memory of the Great Patriotic War, as World War II is known in Russia. Even today, the sound of a Katyusha firing is immediately recognizable to anyone familiar with World War II history. The crews who operated Katyushas were specially trained. While the weapon was simpler than conventional artillery in some ways, effective employment required skill and experience. Crews had to learn to set up the launcher quickly, to calculate the correct elevation and traverse for the target distance and direction, to load the rockets safely and efficiently, and to conduct the electrical firing sequence properly. They also had to master the critical skills of camouflage and rapid displacement. A Katyusha crew that lingered too long in a firing position after firing was vulnerable to counter-battery fire or air attack. Soviet doctrine emphasized the concentration of Katyusha fire. Rather than dispersing launchers to provide support across a wide front, the Soviets would concentrate multiple batteries or even entire regiments of Katyushas on critical sectors. This concentration created overwhelming firepower at the decisive point. When a Soviet offensive was planned, Katyusha regiments would be moved forward, carefully concealed, and then at the appointed time, they would all fire simultaneously. The density of fire achieved through this concentration was far greater than if the same number of launchers were spread out along the entire front. The maintenance of Katyusha systems was relatively straightforward compared to more complex weapons. The launching rails needed to be kept clean and free of damage. The electrical firing system needed to be checked regularly. The truck chassis required normal vehicle maintenance. However, the weapon had no complex hydraulics, no precision optics, no delicate mechanisms that required specialist maintenance. This simplicity meant that Katyusha units could operate with less specialized support than other artillery units, another advantage in the harsh conditions of the Eastern Front. The weather resistance of the Katyusha was good. The rockets could be fired in rain, snow, and extreme cold. The solid propellant used in the rocket motors was relatively stable across a range of temperatures. This was important because the Eastern Front experienced extreme weather, from the heat of summer to the brutal cold of winter. Artillery pieces could freeze, recoil systems could fail in extreme cold, but the Katyusha continued to function. The main weather-related limitation was that snow or mud could restrict vehicle mobility, but this affected all ground vehicles, not just Katyushas. The integration of Katyushas into combined arms operations became a hallmark of Soviet military doctrine. In a typical Soviet offensive, the attack would begin with a massive artillery preparation. Conventional artillery would fire for hours, systematically destroying identified targets. Then, just before the infantry and tank assault began, the Katyushas would fire their salvos, saturating the defensive zone and shocking the defenders. Immediately after the Katyusha salvos, the assault troops would advance. The timing was critical. The shock effect of the Katyusha bombardment was greatest in the immediate aftermath. If the assault was delayed, defenders could recover, but if the assault followed immediately, the defenders would still be stunned and disoriented. The number of Katyushas produced during World War II is difficult to determine precisely because Soviet wartime production records are incomplete, but estimates suggest that around 10,000 launchers of all types were produced, along with millions of rockets. This level of production made the Katyusha one of the most numerous artillery systems in the Soviet arsenal. By comparison, the Germans produced a few thousand Nebelwerfers, and American rocket artillery production was even lower. The scale of Soviet Katyusha deployment was unmatched by any other nation during the war. The targeting of Katyushas improved as the war progressed. Early in the war, targeting was relatively crude, based on map coordinates and estimated ranges. As Soviet artillery doctrine became more sophisticated, forward observers, aerial reconnaissance, and intelligence reports provided better targeting information. Katyusha fire could be directed based on observed enemy movements, identified concentrations of troops or vehicles, or predicted enemy positions. The Soviets also began to use Katyushas for counter-battery fire, bombarding areas where German artillery was believed to be positioned, though this was less common than using them against frontline troops. The psychological warfare aspect of the Katyusha was leveraged by Soviet propagandists. German prisoners were interrogated about the weapon, and their descriptions of its terrifying effect were used in Soviet propaganda to boost morale among Soviet troops and civilians. The message was clear. The Red Army had powerful new weapons that the Germans feared. This propaganda was not inaccurate. German troops genuinely did fear Katyusha attacks. and this fear affected their morale and combat effectiveness. The defensive use of Katyushas was also significant. When German forces attacked Soviet positions, Katyushas would fire on the German assault formations, breaking up attacks before they could reach Soviet lines. The ability to deliver sudden, massive firepower on advancing troops was enormously valuable in defense. German officers planning attacks had to account for the possibility of Katyusha fire, which complicated their planning and forced them to disperse their forces more than they might otherwise have done. The Katyusha's role in urban warfare was particularly important during the Battle of Stalingrad and later during the assault on Berlin. In urban terrain, where buildings provided cover and concealment, the area saturation capability of the Katyusha was extremely effective. A salvo could bombard an entire city block, collapsing buildings, creating rubble, and forcing defenders out of their positions. The rocket's high angle of fall meant they could strike targets that were sheltered from direct fire weapons. In Stalingrad, Soviet Katyushas fired across the Volga River into German-held parts of the city, supporting Soviet troops fighting building by building. The legacy of the Katyusha extends beyond its military impact. The weapon became a cultural icon in the Soviet Union and later in Russia. Songs were written about it, not just the famous Katyusha love song from which it took its name, but specific military songs celebrating the rocket launches. Films depicted heroic Katyusha crews defending the motherland. Statues and monuments featuring Katyusha launchers were erected in cities across the former Soviet Union. The weapon became inseparable from the memory of the Great Patriotic War and the Soviet victory over Nazi Germany. The technical legacy of the Katyusha can be seen in modern rocket artillery systems worldwide. The principle of truck-mounted, multiple-launch rocket systems has become standard. Modern systems are far more sophisticated, with computerized fire control, GPS guidance, longer ranges, and more powerful warheads, but the basic concept remains the same. The American M270 MLRS, the Russian BM-30 Smerch, the Chinese PHL-03, all are descendants of the Katyusha concept. These modern systems can fire guided rockets with precision at ranges of 50 kilometers or more, but they still retain the core capability that made the Katyusha effective. Rapid fire of multiple rockets to saturate an area with explosives. The simplicity of the Katyusha design has also influenced insurgent and irregular forces. Various groups around the world have created improvised rocket launchers based on the Katyusha principle, mounting simple rocket tubes on trucks or even trailers. These improvised systems lack the sophistication and reliability of purpose-built military equipment, but they demonstrate that the basic concept is accessible and effective even with limited resources. This has made Katyusha-style systems attractive to non-state actors and irregular forces in various conflicts since World War II. The German soldiers' accounts of Katyusha attacks provide valuable historical insight into the weapon's effectiveness. Letters intercepted by Soviet intelligence, interrogations of prisoners, and post-war memoirs all describe similar experiences. The sudden onset of the attack, the lack of warning, the intensity of the explosions, and the psychological trauma were consistent themes. Some German soldiers described being unable to hear properly for hours after an attack due to the concussions. Others described panic attacks triggered by any sound that resembled the howling of incoming rockets. The psychological casualties from Katyusha attacks, soldiers who became combat ineffective due to the trauma, were significant though difficult to quantify. The training of Soviet Katyusha crews emphasized both the technical operation of the weapon and the tactical employment. Crews practiced loading and firing drills until they could complete the process quickly and efficiently. They learned to recognize different types of terrain and to choose good firing positions that provided concealment and rapid egress routes. They studied German tactics to understand how the enemy might attempt to locate and destroy Katyusha batteries. The best crews became highly proficient, able to fire a salvo, reload, and be ready to fire again in minimal time, or to fire and displace to a new position within minutes. The coordination between Katyusha units and other Soviet forces required careful planning and communication. When Katyushas were firing in support of an attack, the timing had to be precise to avoid hitting friendly forces. The rockets' lack of precision meant that they had to be fired at targets well ahead of advancing Soviet troops. Forward observers would communicate with Katyusha batteries, providing targeting information and confirming when fires should be lifted or shifted. This coordination became more sophisticated as the war progressed and Soviet artillery doctrine matured. The impact of the Katyusha on the course of the war is difficult to isolate from the many other factors that determined outcomes, but it was certainly significant. The weapon provided Soviet forces with a unique capability that the Germans had difficulty countering. It contributed to the success of major Soviet offensives, helped to defend against German attacks, and imposed psychological strain on German troops that affected their combat effectiveness. While it would be an exaggeration to say that the Katyusha won the war for the Soviet Union, it would be equally wrong to dismiss it as just another weapon. The Katyusha was a key component of Soviet military power on the Eastern Front, and its impact was both material and psychological. The story of the Katyusha is also a story about innovation under pressure. The Soviet Union in the 1930s and early 1940s was under enormous pressure to modernize its military and develop new weapons. The purges of the late 1930s had devastated the Soviet military leadership and had created a climate of fear that stifled innovation in some areas. Yet weapons like the Katyusha were developed successfully. This suggests that despite the political repression and the chaos of the period, there were talented engineers and designers in the Soviet system who could create effective military technology when given the resources and the mandate to do so. The Katyusha also illustrates the importance of mass production and logistics in modern warfare. Having a brilliant weapon design is not enough if you cannot produce it in quantity and get it to the troops who need it. The Soviets excelled at this during World War II. They designed weapons that could be mass-produced with available materials and industrial capacity. They evacuated and rebuilt factories under incredibly difficult conditions. They organized supply chains to move weapons and ammunition from factories to the front lines across vast distances. The Katyusha's success was as much about Soviet industrial and logistical capability as it was about the weapon's design. In the final accounting, the Katyusha rocket launcher stands as one of the iconic weapons of World War II, as recognizable and significant as the T-34 tank or the Il-2 Sturmovik ground attack aircraft. It terrorized German troops, boosted Soviet morale, demonstrated Soviet technical capability, and pioneered a form of artillery warfare that continues to this day. The howling of its rockets became the sound of Soviet offensives and of German defeat on the Eastern Front. For the men who experienced Katyusha attacks, whether they were German soldiers in bunkers or Soviet soldiers advancing behind the barrage, the weapon left an indelible impression. The Katyusha was more than just a weapons system. It was a symbol of Soviet determination, a tool of modern warfare, and a harbinger of the rocket artillery systems that would dominate battlefields for decades to come. When we hear the name Katyusha, we are reminded of the brutal combat on the Eastern Front, of the sacrifices made by soldiers on both sides, and of how a relatively simple weapon, used effectively and in mass, can change the nature of warfare and alter the course of history.